All right, welcome back to the second part of lesson 4 in unit 4. And today we're going to be looking at the stuff to make you think and the tough stuff in the area models lesson. So flip over to page 18 and we'll get started. So we talked about using the area models to help us multiply numbers. And we looked at some large ones with addition as well. And in this section here, things get a little bit tougher because they add some different shapes and some different types of problems in here. Okay, so here's 16 through 19. Match each numerical expression with one of the area models. You may use the same model more than once. Okay, so here we have 2 times 3 plus 4. So you got 3 plus 4, so that's like a long segment, and then you're going to multiply it by 2. So you got 2 plus 4 times 2. So this would be B. Okay, because this one has a 1 on it. So here, and the parentheses do make a difference. Okay, here you have 2 times 3 plus 4. Okay, well, the 4 does not get the 2 here. Okay, so that would be like a 4 times 1. Okay, so you got 2 times 3 and a 4 times a 1. So this is A. You have a 4 plus 3 times 2. Now that's this just backwards. So 4 times 1 plus 3 times 2. So 4 times 1, 3 times 2. That's also A. 2 times 3. So 2 times 3, that's this one. Plus 4 times 2, that's this one. So this is B. Okay, so different ways to model it. Find the total area of each of these shapes. So shape A, 2 times 3 is 6, 4 times 1 is 4, 6 plus 4 is 10, and that would be units squared. Okay, area is always whatever the units are squared. So this one didn't give us any units, so we'll use units squared. Perimeter is a length, so it is just whatever the unit is. So shape B, you got 2 times 3 is 6, 2 times 4 is 8, 8 plus 6 is 14 units squared. Okay, 22, in each of the box, put the product of the numbers that point to it. Okay, so you got 5 times 5 is 25. 3 times 7 is 21. Negative 3 times negative 3 is 9. Negative 5 times negative 1 is 5. 5 times 9 is 45. And 7 times 7 is 49. All of these being multiplication facts that you should be comfortable with. Negative 10 times negative 10 is 100. And negative 8 times negative 12, maybe not so comfortable on that one, is 96. Okay. 8 times 2 is 16. Here's your 6. Carry the 1. 8 times 1 is 8, plus the 1, 9. How are the numbers in the green boxes related to the numbers in the red boxes? So red to green. Okay, if you notice here, green is 4 less. Than red. If the number in the red box is 2025, what will the number in the green box be above it? So the green is 4 less, so that'd be 2021. So you would just subtract there. If the number in the red box is C, what will the number in the green box be above it? So whatever C is minus 4, you got to take that away. Could the number in the green box ever be negative? So could these numbers up here ever be negative? Okay, well, if we look at the numbers down here, these were all positive, these were all positive, these were all negative, these were all negative. there's one case that we didn't have, and that was maybe a negative over here and a positive over there. So yes, you can get a negative if one and only one of the factors is negative. Okay, like -5 and 3, or -5 and 5. Okay. One of them's got to be negative. All right, here we have another mystery grid here with 1, 2, 4, 8. So it gives us this is 2. Multiplied to get 8. Well, that could be 8 and 1 or 2 and 4. Okay, can't use that. Add to get 5. That's going to be a 1 and a 4. Add to get 6. 2 and 4. Add to get 9. That has to be a 1 and an 8. So I know 8's going here, or a 1. So that means this can't be a 1. This has to be a 2 or a 4. Add to get 12. Be 8 and 4. Okay, so 8's going in this right here. So this has to be a 4. This would be your 8. This has to be your 4. This would be your 2. Okay, so 4 is going here. So this has to be 1 and 4. So 1, this would be 2 and 8. This would be 1. So 1, 2, 4, 8. 8, 4, 2, 1. 1's already here. So this would be 8. This would be 1. 1, 2, 4, 8. 1, 2, 4, 8. So there we go. So a little bit tricky. We had to do some more work on that one to get the final answers. Okay, here on page 19, we're looking at some trickier models here. So match each numerical expression with one of the area models. You may use the same model more than once. Okay, so we have 3 plus 4 squared. So that means you're going to take 3 plus 4 in a segment and you're going to make a square out of it. So 3 and 4, and you have a square 3 and 4. So this is B. You have 3 times 4 squared. So you have a square with 4 by 4, and you actually have 3 of them. So this happens to be C. You got 3 4 by 4 squares. That's what this says. 3 4 by 4 squares. You have 3 times 4 squared. Okay, that's a little bit tricky. Okay, you have 3 times 4 squared. So really, if we look at this, we have 3 4 times, and then that makes the square. So we have 1, 2, 3 4s, but it doesn't make a giant square. Here we have 1, 2, 3 4s, and it does make a big square. So this is A. Hey, that one's a little bit tricky. Hey, you can kind of do a little bit of math here. 3 times 4 is 12. So you have a length of 12 that makes a square. So 4, 5, 6, 7, 8, 9, 10, 11, 12, and it makes a square. Here you have 3 squared plus 4 squared. So you have a 3 by 3 and a 4 by 4, and you're just adding those two things together. So here you got a 4 square and a 3 square, and you don't have anything else. Here you have other things. So this is D. 3 squared plus 4 squared. Okay, so here's a 3 squared and a 4 squared, 3 squared. So it's one of these two, plus 2 times 3 times 4. Okay, this one didn't have any extra. This one, let's look at it. I got 2 yellow squares, and the yellows are 4 by 3. 4 by 3. So this is B. And 3, you have a 3 squared times a 4 squared. Okay, so 3 squared is 9. So you have 9 of the 4x4 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9 4x4 squares. Okay. You have a 3x3 square. Well, 1, 2, 3, 1, 2, 3. Okay. 3x3 square, but then it's a 4. Each one of those is a 4x4 square. So this is A. Find the total area of each of the shapes. Okay. So 4x4 here is 16. So each one of these is 16. Or you could look at it, this is 12. And this is 12. And 12 times 12 is 144. Okay, you probably know 12 times 12. Okay, this one's 16, 16, and 16. So you could add that up. Or you know this is 12. 12 times 4 is 48 units squared. This is, oh, I did it wrong. That was shape C. So this is 48 units squared. This down here is B. So you get 16, 12, 12, and 9. You get 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Carry the 1, 2, 3, 4. So 49 units squared. Shape D, this is 16 and 9. 9, 10, 11, 12, 13, 14, 15. Carry the 1, 25 units squared. Okay, these are a little bit rough. Okay. Which of these expressions go with this diagram? Circle all that apply. Okay, so you got 5 plus 5 times 6 plus 4. Okay, that one's good. You have 30 plus 20 plus 30 plus 20. So 5 times 6 is 30. This is 30. This is 20. This is 20. So 30, 30, 20, 20. This applies. That's good. And then you have 6 plus 5. I don't have a 6 plus 5 anywhere, or a 4 plus. I don't have that anymore. We can only add these. We don't add these numbers together, which is what they did. So not that one. Which of these expressions go with the diagram? Circle all that apply. So you have 5 plus 5. Nope. You got 45 plus 54. Whoop. Okay, 45 plus 54. Whoop, 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 whoop. Or 6. Let's add these. So you got 20. You got 6 times 4 is 24. 25 and 30. So this is 55 or 44. I'm just trying to see how I can get those numbers there. 6 plus 5 times 4 plus 5. Yeah, that one works. So this is 44. There's 45 and 54. Okay, so if I add this way, I get 45. Add this way, that's 54. So that one does work. A little bit tricky on that one. Okay, use the area model here to do this problem. So we have 10 times 1 and 10 times 3. So 10 times 10 is 100. 10 times 1 is 10. 10 times 3 is 30. 3 times 1 is 3. So you got 3, 30 and 10 makes 40, and 143 there. Okay, here we got a little negative here. Okay, so we got 12 minus 1, which would be 11, and 12 plus 1, which would be 13. So this should get us the same number. 12 times 12 is 144. 12 times 1 is 12. 12 times -1 is -12. So actually those two will go away. And -1 times 1 is -1. So you have 144 minus 1 is 143. So we did get the same number in a little bit different method. In each box, put the product of the numbers that it points to. So 12 times 12 is 144. 11 times 13, which we did twice, is 143. Okay, look, it went away one number. Okay, and 1 times 1 is 1. So you minus 1 number there. Okay, match each of the numerical expressions with an area model. You may use the same model more than once. Okay, again, this is a little bit harder stuff. We've got fractions in here. Okay. So here we have 3/2 plus 4/2. Now 3 times 1/2, that is 3/2. And 4 times 1/2 is 4/2. So this one is A. 3 plus 4 times 1/2. So this is 3 plus 4. And then times 1/2, this is also A. Notice this one we have two different numbers out here. So 3/2 plus 4. Well, 4 times 1 is 4. 3 times 1/2 is 3/2. And then I would add those together. This is B. Ooh, 3 plus 4 all over 2. Okay, so 3 plus 4 divided by 2. Divided by 2 is cutting it in half. Well, this is 3 plus 4, and it's only half of it. The whole thing would be here, but we cut it in half. So this is A, because we cut that one in half. Okay. Another mystery grid, 1, 2, 3, 4. Okay, division, you get 4. It'd be a 4 and a 1. 6 with multiplication, 2 and 3. 6 with addition, 3 numbers. So that could be a 4 and a 1 and a 1. That could be a 3, a 2 and a 1. We're not sure there. So addition with 7, 2 numbers, that's 4 and 3. A 4 is going in this row. So that means this is a 3, this is a 4. 3 is already here, so that's a 2, that's a 3. So this must be a 1. Okay. This column needs a 1 somewhere. It could be here. Addition to 10. That could be a lot. I need 4 numbers there. That could be quite a bit. So this needs to be a 3, a 2. I need a 1 and a 4 somewhere. 8. Multiplication, you already got a 1. So that'd be a 4 and a 2. Somewhere there. So this one already has a 4. This one already has a 4. This one will have a 4. So this up here has to be a 4. Because I got a 4 here. One of those will be a 4. One of those will be a 4. So none of these could be a 4. That one's got to be a 4, which means this has to be a 1. So now I need to get a 5. I could still have a 4 and a 1. Okay. Let's look at 3s. Definitely tough puzzle here. So 4 and a 2, a 4 and a 1. Okay, 1's already here, so this has to be a 4. This has to be a 1, which you got a 1, a 1, a 1. So this has to be a 1. Only way it could go in there. 1, 2, 3, 4. Okay, 4's there, so this has to be a 2 and a 4. 1, 2, 3, 4. 1, 2, 3, 4. So 3 plus 2 plus 1 is 6. 4, 5, 6, 7, 8, 9. That has to be a 3. Ooh, that was tough. That was a tough one. Okay, so on page 20, you have your additional practice here to work on, and then there will be a quiz on the lesson 4 stuff. If you ever have any questions, feel free to message me and ask away. If not, I'll see you in lesson 5.